Welcome back to the video series on the solutions to the preparatory exam. In this question, we have a circle geometry problem where we're asked to find angle SPR. This is angle SPR, the angle here, as well as QSR, the angle here. Well, I believe this is a simple question, and sometimes circle geometry comes in both part A and part B of the theory questions, that is the compulsory and the optional questions. So you have to practice enough questions before you go for the exam. Now, to find angle SPR, if I look closely at the triangle RPS, once I know the angle here and the angle here, to be easy for me to find angle SPR. The angle RSP is quite easy to know because it is an angle opposite to angle RQP. Angle RQP here and angle RSP, they are opposite angles of a cyclic quadrilateral. That means I can say angle RSP plus angle RQP equals to 180 degrees because they are what? Opposite angles of a cyclic quadrilateral. So that means RSP plus 100 is 180 degrees. That would mean that RSP is 180 degrees minus 100 degrees, which is 80 degrees. That's the value of the angle here, 80 degrees. Now that I know angle RSP, what about angle PRS? Well, angle PRS is also quite easy to find. If you look at the tangent and the chord that makes contact with the tangent, that is the chord PS, trace the two edges of that chord, the chord PS or SP. If you look at the two ends of the chord and trace the line joining it to the circumference of the circle, that is from this vertex S, you say that it makes an angle at R, and from P as well, there is a line that makes an angle at R as well. So that means angle SRP, which is here, is equal to angle 21 degrees because they are in alternate segments. So that means this is 21 degrees. If we also look carefully at this SP again, the two ends of this chord is also making an angle at Q. S and P, the lines drawn from them have also made another angle at Q. That means this angle right here, just this PQS, is also 21 degrees. Now that I know the angles in the triangle SRP, let me draw a sketch. So this is vertex S, this is P, and this is R. We found R to be 21 degrees. The angle at S is 80 degrees. That's RSP. I want to find angle SPR. That means we can now find angle SPR by removing it from the sum of angles in the triangle. So we say angle SPR plus 80 degrees plus 21 degrees equals to 180 degrees because they are angles in a triangle. SPR plus 101 degrees equals to 180 degrees. That means SPR equals to 180 degrees minus 101 degrees, and that will give us 79 degrees. Now that we know the value of angle SPR, let us look at the second part of the question, which asked us to find the value of angle QSR, which is right here. We want to find this angle. There are two, or let me say there is more than one way to solve this particular question. If you look closely, QS is a diameter because it passes through the center. So if QS is a diameter, that means OS is a radius, right? And remember that a radius is perpendicular to the tangent, right? So that means OS is perpendicular to tangent TS. That would mean that angle OST is equals to 90 degrees. OST. The angle here is 90 degrees. So if the entire angle right here is 90 degrees and PST is already taking 21 degrees, this PST is taking just 21 degrees. That means the rest of the angle here, let me use another ink. The angle right here is going to be, when we take away 21 degrees from 90 degrees. So let me clean it. The entire angle here is 90 degrees because OS is perpendicular to ST. Now, from these 90 degrees, PST has taken 21 degrees. That means if we want to find QSP, just this angle QSP, if we want to find just angle QSP now, angle QSP is going to be taking away 21 degrees from 90 degrees, and that's 69 degrees. So if this place is 69 degrees, remember that the entire angle RSP is what? 80 degrees. This angle right here, this entire angle is angle RSP, which we've calculated as 80 degrees. This is 80 degrees. So if the entire RSP is 80 degrees and just QSP, the one right here, this angle here, this one is 69 degrees and everything is 81 degrees. That means the rest of the angle here will be what? Taking away 69 degrees from 80 degrees. So that means angle QSR, this is Q, this is S, and this is R. That means this angle that we are looking for is the difference. Okay, when we add it to angle QSP, it is going to be equal to angle RSP. Let me come again. The entire angle here is 80 degrees, the whole of angle RSP. So out of the RSP, you can say that we have QSP, and we also have QSR. That means RSP, which is 80 degrees, will be equal to QSR that we are looking for plus QSP. And this QSP that we just finished calculating, which is 69 degrees right here. So that means QSR plus 69 degrees equals to 80 degrees. That would mean that angle QSR equals to 80 degrees minus 69 degrees. Which means QSR is 11 degrees. I forgot to write the reason for saying angle OST is 90 degrees here. So the reason is that OS is perpendicular to TS. So that's the solution to this question. A tower and a building are on the same horizontal ground. Okay. Let us sketch that. So this is the horizontal ground. An engineer on top of the tower, well, let's say this is the tower. And we are given that the tower is 110 meters high. Observe that the angle of elevation of the top of the building. So this information is clearly telling us that the building is higher than the tower in this case, because if the engineer is on top of the tower and he observes an angle of elevation, that means the building is taller. So that means let's call the foot of the tower point P, and let's call this is point Q, the foot of the building. So that means we are going to draw something longer for the building. Now, so the angle of elevation of the top of the building and the angle of depression of the foot of the building are 38 degrees and 32 degrees respectively. So let's work with angle of elevation first. That means the angle made from this place where the engineer is to the top of the building. We are told that that angle of elevation is 38 degrees. So let me just... So this place is 38 degrees. And the angle of depression of the foot of the building, this point Q, the foot of the building, is 32 degrees. I just realized that there's an error with the question, even though it's not as if it is not possible, but the correct value here is 22 degrees. So let's proceed. Now, the angle of depression from this point where the engineer is to the foot of the building is 22 degrees. So if I draw another line, this is 22 degrees. Calculate correct to 1 decimal place the distance between the tower and the building, that is from here to here. And at the same time, the height of the building, that is from this point to this point. Let's call this point R, and let's call this point S. We can as well call this PQRST. Let's call this T. Now that we have a sketch of what the question is, or what information we have in the question, let's proceed to solving the question. Now, for us to calculate the distance between the tower and the building, well, from rules of alternate and corresponding angles, would notice that this angle 22 degrees this angle here, it will be alternate to the angle at Q, that is angle PQT. The reason being that this RT and PQ will be parallel to each other. So this TQ is serving as a transversal, and we know that one of the angles that can be formed is alternate angles. Therefore, this angle right here is definitely 22 degrees. So now that we know 22 degrees, the angle between the angle TQP, and we are looking for PQ, we can use the trig ratio tangent, that is tan 22 degrees is opposite, which is TP, divided by adjacent, which is PQ. Now, our opposite side is 110 meters. So I'll just write 110. So tan 22 is equal to 0.4040 equals to 110 divided by PQ. That means PQ will be equal to 110 divided by 0.4040, and that will be equivalent to 272.277 meters. We are asked to leave our answer correct to 1 decimal place. That means the distance between the tower and the building is 272.3 meters, 1 decimal place. Now that we found the first part, we're asked to calculate the height of the building. Well, the height of the building here is SQ, right? From this point here to this point here. Now, we already know RQ. And how do we know RQ? Since TP is 110 meters, that means definitely this place is also 110 meters. That means if we're able to calculate from R to S, the distance from R to S, let's represent it with H. So if we are able to calculate RS, then we can add it to 110 meters to get the height of the building. But how do we calculate for RS? Let me just sketch out the diagram, the triangle. Point S, point R, point T. We know this to be 38 degrees. We are looking for SR that we've represented with H, and we need either the hypotenuse or the adjacent. But we already know the value of the adjacent side, which is side RT, because this side RT right here from the main diagram, this right here, will be equal to PQ. And remember that we just calculated PQ. So that means this place will be equal to 272.277 meters. Please, when you are solving questions and you are using a value from the previous, you are using a value that you calculated by yourself, please do not use the approximate answer. What do I mean? Here, we approximated our answer to be 272.3 meters. But now you will not approximate your answer when you want to you will not use the approximate value when you want to use that value to solve a question. So now that we know an angle and a side, we can use tan as well, because we have the opposite and adjacent side to the angle. So that means tan 38 degrees equals to opposite, which is H, divided by 272.277. That means tan 38 is equal to 0.7813 equals to H over 272.277. That means H equals to 0.7813 multiplied by 272.277, and you will get 212.730 meters. Now, what we just finished calculating is the distance from S to R, this distance right here. But we're asked to find the height of the building. That means the height of the building will be equal to the sum of 212.730 meters and 110 meters, and that will be equivalent to 322.730 meters. We are actually going to approximate that as well to one decimal place. That's 322.7 meters to one decimal place. So that's the solution to this question. A man wishes to keep some money in a savings deposit at 25% compound interest so that after 3 years he can buy a car for 150,000. How much does he need to deposit now? The question is basically asking us for the principal. Now, the 150,000 is referring to the amount. Say, for example, you took a loan of, say, ₦1 million from a bank and you're returning 1.2 million or 1.5 million. That price or that money you're returning is the amount, while the money you borrowed is the principal. So in this case, the rate is given to be 25%. The time is given to be 3 years. And the amount is given to be 150,000. All we are required to find is the principal. Now, we can solve compound interest questions by solving it one by one, but there's also a formula for it. So the formula for calculating the amount of compound interest is P, which is the principal, into bracket 1 plus R over 100 raised to power t. So in our case, we have the amount, which is 150,000, equals to p into 1 plus r is 25, divided by 100 raised to power t, which is 3. So that means 150,000 equals to p into 1 plus 0.25 raised to power 3. That means 150,000 is p times 1.25 raised to power 3, and that will give us p equals to 150,000 divided by 1.25 raised to power 3. You can press this directly on a calculator or even write the full answer of 1.25 cube, which is 1.953125, and that will give us 76,800. So it needs to deposit 76,800. In a class of 64 students, each student offers either physics or mathematics or both. If 50 students offer mathematics, well, let's start to interpret the question. The universal set is 64. 50 students offer mathematics. Number of mathematics students is 50. And the number of students offering mathematics only. Number of students offering mathematics only is twice the number of students offering physics only. M complement intersection P. How many students offer both subjects? That is M intersection P. Now, please note one thing, that when you hear only or but not in set problems, it is different from, say for example, when you hear 10 students offer biology only, it's different from 10 students offer biology and chemistry, right? So when you hear only in a 2-word problem, say we are working with P and Q. So when you hear P only, that means you put a complement on Q. This is P only. So it is P intersection Q complement. When you hear Q only, that means you put a complement on P. So Q only will be P complement intersection Q. In a 3-word problem, say we have A, B, C, right? And you hear A and B only. That means you put a complement on C. So it will be A intersection B intersection C complement. When you hear A and C only, that would mean you put a complement on what? On B. So it will be A intersection B complement intersection C complement. So even in a 3-word problem and you hear B only or C only, so if you hear C only now, it will be A complement intersection B complement intersection C. That is, the other two will have complement. Now let's come back to the question. We need to sketch a Venn diagram. Let me do that quickly. Now, I've made a sketch of the Venn diagram. We do not know what the value of M only or P only is. Well, let's represent this value. Oh, I made a mistake in the interpretation. Pardon me. The number of students offering mathematics only, that is this expression here, mathematics only, is twice. That means I'm supposed to write 2 times here. It is 2 times the number of students offering physics only. So, if we represent this particular expression, the number of students offering physics only, let's say we represent it with X. Let X be number of students offering physics only, right? On our Venn diagram, if this circle is for M and this is for P, that means P only will be here, which is x, that we represented with x. So if physics only is x, that means M intersection P complement, that is mathematics only, will be 2x, right? So we write 2x here, and we are asked to find the number of students offering both subjects. Now, we still have two other values that we can work with. What do I mean? We are given the number of students offering mathematics. So if everything in this circle, if everything right here in this circle M is 50 and M only is 2x, that means to find this intersection is no longer hard. The whole of the circle is 50 and M is only taking 2x. That means M intersection B will be what? 50 minus 2x. You just have to take away M only from the total number of students offering mathematics. That means we'll write 50 minus 2x in this intersection. Now that we know the elements of our Venn diagram, we can now proceed to solve. Remember that the universal set, that is the total number of students in the class, is 64. That would mean that 2x, this 2x right here, plus this right here, which is 50 minus 2x, plus this x is equals to 64. Now, if we collect like terms, 2x minus 2x plus x equals to 64 minus 50. 2x minus 2x is 0, and we'll be left with just x. So that means x is 64 minus 50, which is 14. However, the x that we've just finished calculating is not M intersection P. M intersection P is what? 50 minus 2x. That means 50 minus 2x will be equivalent to 50 minus 2 times 14, which is 50 minus 28, and that will be 22. That means 22 students offer both mathematics. 22 students offer both subjects. In this question, one of the parallel sides of a trapezium, well, let's just quickly sketch a trapezium. So this is a rough sketch of a trapezium. Now, one of the parallel sides of a trapezium is 1/3 the length of the other. If the height of the trapezium is 5 centimeters, so this height, the distance between the parallel lines is the height, is 5 centimeters, and its area is 120 square centimeters. Find the length of the parallel sides. Well, we are not even given any of the parallel sides. We are just given the relationship between the two. So let's say the longer side, let's represent it with x. So let x equals to the longer parallel side. So if this is x, we are told that the other length is 1/3 of x. That means 1/3 x, or x/3. Now we are given the value of the area. Remember that the formula for area of a trapezium is A equals to 1/2 the sum of the parallel sides multiplied by the height. So in this case, A is given to us to be 120. So substituting it into the formula, we have 120 equals to 1/2 into A plus B. If we use this 1/3x as our A, that means x/3 plus B, which is x, the second side, the second parallel side, times h, which is 5. That would mean 120 equals to 1/2 multiplied by x/3 plus x is 4x/3 multiplied by 5. So that means 120 equals half times 4x/3 times 5. 2 here 1, 2 here 2x. That means we have 120 equals to 10x divided by 3. So if we cross multiply, we'll have 120 times 3 equals to 10x, and x is going to be 120 over 120 times 3 divided by 10, and that's 36 centimeters. That means the longer side of the trapezium is 36 centimeters. So if the first side is 36 centimeters, the other side is going to be 1 over 3 times 36 centimeters, which is 12 centimeters. Therefore, the length of the parallel sides are 12 centimeters and 36 centimeters.